So in this wee video, we want to look at the integration of hyperbolic functions. And just before we start, a few wee things just to remind ourselves of identities that we've seen earlier. That cos squared x minus sine squared x is 1. We know that sine 2x is 2 sine x cos x. And we know that cos 2x is cos squared x plus sine squared x. And like I said here, we can adapt both the first and the third ones can be mixed in to eliminate cos squared or sine squared. And so when we do that, we'll end up with, if we want to find out what sine squared x is, then in terms of cos 2x, it's going to end up as a half of cos 2x minus 1. And likewise, if we wanted to eliminate sine squared x and got cos squared x, we would find then that that's equal to a half of cos 2x plus 1. Okay, and all of these can come into play whenever we're integrating hyperbolic functions, so that it's good to know those or have them handy. But basically in our integration, the basic integrals can be got just from the reverse of differentiation. We know that when we differentiate cos x, we get sine x. So when we go in reverse, when we integrate sine x, we're going to get cos x. And it carries on like in trig integration. So sine ax, we know is going to be 1 over minus cos ax. And in this case, sine ax will integrate to give 1 over a cos ax. Likewise, we know when we differentiate sine, we get cos. So when we integrate cos, we're going to get sine. And so the integral of cos ax dx is 1 over a sine ax plus c. Tangent is quite a nice one. Again, it's a fraction sine over cos. That's the function f dash of x over f of x. And so when we integrate that, it ends up being the log of f of x. So in this case, the log of cos x plus c. And again, we can extend that for the integral of tangent ax is 1 over a times the log of cos ax plus c. So those are the three basic ones. All others then we solve in similar fashions to what we did when we had trigonometric functions. So when we had sine squared and cos squared, what we did was we wrote those functions instead of in terms of cos 2x. And same for sine and cos squared. We change it for cos 2x. Like in the previous page, we saw that the substitutions that we can make there. Where we had sine cubed and cos cubed, what we did was we took out a factor of sine or cos squared. And same thing with sine and cos. So here's sine cubed, cos cubed. You can take out a factor of sine or cos and you're left with an even power of sine or cos again. And then we can use again our substitution. In this case, cos squared minus sine squared is 1. We've got our log answers when we integrate, and we can use the product and sum formula as well when we integrate. And also then one of the familiar ones was when we had a single sine or a single cosine mixed with a power of cos or sine, and we knew that would be 1 power greater for the sine or cos. Same sort of thing for hyperbolic functions. Sine x cos to the power of nx is going to give us an answer in the form cos of n plus 1 to the power of x. Likewise, cos x times a power of sine x is going to be 1 power of sine x more. So an example here, the integral of cos x sine squared x, it's of that format, and I know that it's going to be sine cubed x. I just need to adapt it. And the way that I do that is just by observation. I know that if I differentiate sine cubed x, I'm going to get 3 times sine squared x times the differential of sine x, which is where the cos x comes from. So that's 3 times what I'm actually looking for. So I'm going to have to differentiate a third of that to get what I'm looking for. And so if I integrate this, I get a third sine cubed x plus c. And again, integration by parts is still applicable. So just a few quick examples here, see how we get on. The integral of sine 6x then, well, it's sine integrates to give cos 6x, and we're going to divide by the differential of 6x, which is 1/6, multiply by 6 there. Don't forget your plus c in the end of that. Cos x, that's another quite nice one just to watch out for. That's cosh x over sine x dx, and I know that when we differentiate sine, we get cosh. So when we differentiate the bottom function, we get the top function, and so that's going to be a log answer. So it's the log of sine x plus c. Cos cubed then, this is one of these ones where we can take out a factor of cosh. So that's going to be the integral of cosh x upon cosh squared x dx. Now, that then is cosh x upon, when we change cosh squared x, we can rewrite that as 1 plus sine squared x. And again, when we multiply that out, we get cosh x plus cosh x sine squared x dx. Now this first term, nice and easy. And when we integrate cosh x, we get sine x. And when we integrate this second term, it's of the form sine cubed x. And it's going to be a third of that plus c. This fourth one then, just again, something to look out for. I quite like to do this, just when you can see this as something similar to the previous one, where if we wrote that as cosh x to the power of -2, what we've got is a single sine x times a power of cosh x. And so I know that that's going to be end up of the form of cosh x to 1 greater power. And then we're going to divide through by that part, so it's going to be minus cosh x to the power of -1 plus c. Now, cosh x to -1 is 1 over cosh x, which is sec x, so you can also write that as minus sec x plus c. So again, when you spot this pattern of single sine times a power of cosh, single cosh times a power of sine, then it makes the integration a wee bit easier. So two more just to have a quick look at. For sine squared x, so in this one here, that again, sine squared x, we're going to change that in this case in terms of cosh 2x. So this is the integral of 4 times, and when we change sine squared x, that's a half of cosh 2x minus 1 dx, which is multiplied through that, it's 2 times the integral of cosh 2x minus 1, which is 2 times, when we integrate cosh 2x, we get a half sine 2x, and when we integrate minus 1, we get minus x plus c. And so overall that ends up being as sine 2x minus 2x plus c. And as we said as well, then the integration by parts works. So here we have a product x times sine 2x. So let's just define this, that u is equal to x, which means that u dash is 1. B dash then is sine 2x, which means that v is the integral of that, which is a half cosh 2x. So it's a matter of filling that in then. So this is equal to uv minus the integral of v du by dx, or u dash dx. So let's fill this in. This is a half x cosh 2x minus the integral of, well, v times u dash is just v, so that's a half cosh 2x. So again, that's a half x cosh 2x minus, when I integrate cosh 2x, I get a half sine 2x, so that's overall a quarter sine 2x plus c. So again, integration, very, very like trigonometric integration, just need to be careful sometimes with your substitutions.